Welcome to the Hooke's Law Lab. In this experiment, we'll be measuring the spring constants for various springs. For one of these springs, we'll use two different methods to find the spring constant and compare their results.
First, ensure the scale is calibrated and that it points to 0 when nothing is on it.
To determine the mass of the mass holder, place it on the triple beam balance pan. We know the mass holder weighs approximately 50 grams, so we only have to play with the last slider. Once you have it around 50 grams, you might have to adjust the finer slider to get it right on. As you can see, this is really close to balanced.
Hang the elastic band from the stand and then add the mass holder to the bottom of the elastic band. You'll need to measure the initial position of the mass holder. I recommend using the base of the mass holder for this purpose. However, any spot on the rigid mass holder will do. Next, you'll need to add mass and measure the new displacement. Make sure that you use the same spot on the mass holder to measure. After measuring the displacement for several different masses, remove the elastic band and replace it with one of the springs. Again, you'll need to measure the initial position of the mass holder. Next, start adding masses. For each mass, measure the displacement. You'll need to do this for multiple springs. In exercise 2, we'll be setting the spring in oscillation and using a different means of measuring the spring constant. For one of the springs, measure the time required for 10 oscillations. Consider reaction time if appropriate. We hope you enjoyed the Hooke's Law experiment, and remember, if you don't follow Hooke's Law, we'll make you walk the plank.